So, number 2, 81 halves. When you want to maximize something or minimize something, take a derivative, set it equal to 0. And then be careful about whether it's a max or a min. But sometimes you can tell without doing a lot of work. Number 4. At what time is the particle at rest? Alex, what's it mean when it says particle at rest? What would I be looking for? What's 0? Other than Michael whispered it in your ear. What's 0? I mean, you're right, but what equals 0? The velocity equals 0. Alright, if I have acceleration, if I have position, I can take its derivative and get velocity. So 6t squared minus 42t plus 72. Set that equal to 0. I can factor out a 6. And it's an easy problem now. But I did have to take a derivative. I did have to know what particle at rest means. So at 3 and 4, the particle was at rest. Usually that leads to a number line and increasing, decreasing, and max and mins, but this one just asked for when v was 0. Number 6. The position of an object is given below. T is in seconds. In the first 4 seconds, and this is on the calculator, how many times is the velocity of the object equal to 0? So how do I know when the velocity is equal to 0 if I have position? Derivative. Now this is with a calculator, so I could take a derivative by hand, or I could type this in. Let's see, 1/6 cosine 5x minus 1/4 sine of 5x. In the first 4 seconds. So that's telling me I don't only have to look up to 4. Okay, I got to be super careful here, because what is that graph a picture of? I just typed in y. That's the position. So how will I know where the velocity is 0? Velocity is the slope of the position. So you got to be careful. I'm not looking for these zeros. I'm looking for where the slope is 0. So when it changes, or when the slope changes, when there's a horizontal tangent line. So 1, 2, 3, 4, 5. I need to be careful because my window, let's just change it back to 4 to make sure I'm looking at the right thing. All right, 1, 2, 3, 4, 5, 6, 6. I had to zoom in to see that, because those were small fraction things. This one wouldn't have been bad, because you could take the derivative. That would not be a bad derivative to take, and then plot the velocity and look for zeros. So I'm either looking for horizontal tangent lines of x or zeros of v. I changed it to like -1 to 1 because I knew it was really small. My y window is -1 to 1. Number 8. Oh, good. I wanted to do one of these. A bug begins to crawl up a vertical wire at time 0. The velocity is given by the function whose graph is shown on the right. 6 times. It happened 6 times. So, what is that the graph of? Velocity. So let's be careful. At what value of t does the bug change direction? If it changes direction, forget about the picture. If something changes direction, what would I be looking for? What changes signs? I don't need the slope of velocity to change signs. To change direction, I would need velocity to change signs. Because if velocity is positive, I'm going one way. If velocity is negative, I'm going the other way. So when does he change directions? At 6. Describe his movement from 2 to 4. From t equals 2 to t equals 4. How is he moving, or is he moving? What's his velocity? His velocity is 3, so he's moving. His acceleration is 0, but he's still moving up. So be careful about what you're looking at. His acceleration is 0, but his velocity is 3. He's still moving. Number 10. With a calculator, at t equals 1, it sounds like I would need v of 1 and a of 1. And then I could answer those questions. I don't think I'm going to do this one. Because all I'm looking for is v of 1 positive or negative? And then is acceleration positive or negative? And then I could answer moving left, moving right, positive or negative. But you've got a calculator, so find v of 1 and then find the derivative of v. But I would use the calculator to find that derivative, don't do that one by hand. Number 12. Speed is increasing. What would I be looking for speed increasing? A and v have the same sign. So what would I do to figure out where A and V have the same sign? How would I tell that? I mean, I can get a derivative, 6t squared minus 48t plus 90. I can get an acceleration, 12t minus 48. But what do I do with those? Especially if I need to see their signs. What's that? I'll set them equal to 0. See if I can factor out a 6 from everybody on that one. And then I can do number lines. And 5 for my velocity number line. T equals 4 for my acceleration number line. And then I've got to check to see where everybody's positive and negative. Let's see. If I plug in 0, I get 90. I'm trying to go fast here, so I can alternate. I don't need to check everything. Positive, negative, positive. Maybe I want to check one more just to be sure. Like if I plugged in 10, 10 squared is 100 times 6. That's going to blow everything else away, so positive, negative, positive. For acceleration, a of 0 would be negative 48. And if I plug in anything bigger than 4, it's going to be positive. And then what am I looking for? I already answered that part. A and B have the same sign. So let's see. They're both negative from 3 to 4. And and they're both positive from 5 on. Yeah, I wouldn't say two negatives make a positive, but if they're both negative, Warren's right, they're speeding up in the backwards direction. That's right. That's when you're backing down your driveway, you press the accelerator, although if you're in reverse, it's not really an accelerator, which is weird, but you press the gas pedal, you go faster, your acceleration is negative, and you're going backwards. That's a whole different conversation. When is your gas pedal the decelerator? And when is the brake the accelerator? And the answer is if you're in reverse and you press the brake, your acceleration is positive. Because your velocity is sort of trending forward. Number 14. One more, we'll be done. Another particle. Oh, I'm glad I'm doing 14. I hope the other class watches this video, and I hope you watch the other class video, but 14. A particle, I'm trying to give you hints here. Let's look at 14. Triple star highlight. A particle moves along the x-axis so that its position is given by this thing. Oh, there's an A in there. That's kind of weird. A is a constant. For what value of t is the particle moving to the right? Okay, so don't worry about that weird equation. How do I know if something's moving to the right? Just in general, what would I be looking for if a particle's moving to the right? Positive velocity. So I need velocity to be positive. Okay. In this question, I don't have velocity. I have position. So how do I get velocity? Take the derivative. Okay, so I need to take the derivative of 1/2 a minus t squared. All right, we'll bring the 2 down front. A minus t to the 1, because we decreased the power by 1. And then there's one more thing to consider. The derivative of the inside, which is, a is a constant, but what's the derivative of minus t? Negative 1. So clean all that up. 2 and 1/2 goes away. I'll just put the negative out front. A minus t. Or negative a plus t, however. That's my velocity. Okay, so what is it asking here? So I want to know when that velocity is greater than 0, when v is greater than 0. So when negative a plus t is greater than 0. Oh, I'm almost there. So when t is greater than a. But that was a tricky one. Take a derivative with the chain rule. No moving to the right means velocity is positive. A lot of stuff going on there.